let's continue along this vein of symmetry of parabolas. Now, when we were talking about linear equations, a super vital part of everything that we talked about was the slope of a line. And we could find the slope of a line by taking any 2 points along it and taking the ratio of the difference between their y-coordinates to the difference between their x-coordinates. We haven't, however, considered the slope of a curve yet, of the graph of anything that isn't just a straight line. This may seem a little bit funny to think about, but I think it's pretty important. There isn't a single slope that applies to every single point along this curve, but we can talk about slope in a local sense. It's pretty easy to see what the slope of a single part of the curve is by picking a point on the line, let's say this one, and drawing a line that just touches the curve at that point and has the same slope as the curve does right there. So for every point on a curve, we can say that there's a line tangent to that point that has the same slope as the curve at that point and barely touches the curve right there. So it's actually really hard to draw an exact tangent line, but this is a pretty good approximation. If we pick 2 points that are infinitesimally far away from this point, or in other words, 2 points that are as close as we could possibly pick to this point that we're interested in, we can draw the line connecting those 2 points and then extend that line to end up with the tangent line. Now, you'll have to wait for calculus to get a really deep and rigorous understanding of tangent lines, but they're still really useful for us for understanding the shapes of parabolas and of other curves as well. So now I've drawn 3 different lines that are tangent to 3 different points on this parabola. I've labeled them A, B, and C, and for each of those, I'd like you to tell me what the sign of the slope of the line is. Is it positive, negative, or 0? Check the proper box for each line.